Hello everyone, welcome to the channel and I hope everyone is doing good. So in the previous video we have seen that what are the interview question in the RAG, be it a scenario based question or a direct question. In today's video we are going to look into the evaluation matrix or how you will evaluate the RAG pipeline. So once you have created the RAG pipeline, so it's very necessary to evaluate your RAG pipeline at different position or different section of the RAG. Like there are retrieval section, there are contextual section. Then LLM also creates the answer with the help of the retrieved information from your external database or a vector database. So we have to look into each matrix. We have to understand that the result which your RAG system gives is correct or not. If it is not correct, then what is the percentage of error or percentage of noise in that answers? So we directly jump into how these things work. This will be a very detailed video, and after this video, you will come to know about how to evaluate your full RAG pipeline, and this is also going to help you directly in the interview. So guys, if you have not subscribed to my channel, then do subscribe to the channel, and please spread this video and channel to your friends, your colleagues who want to move into data engineering field, who want to get into GenAI pipeline, and you who want to excel or want to learn more about the D pipeline data engineering topics. So the first question is, why are traditional NLP metrics not suitable for RAG evaluation? So before GenAI, there was NLP. NLP is still there is NLP, but NLP is the base of this GenAI pipeline. So NLP means natural language processing, and in that, why the metrics or the tool which we are using to evaluate the NLP is not relevant in the RAG pipeline. So there are multiple tools. You can see BLU, ROG, Meteor, Perplexity, Traditional Accuracy. These were the form, these were the ways by which we used to evaluate the NLP system, NLP words, NLP sentences. But these are not relevant because they just focus on the word overlap. Not much of the contextual meaning was checked. Grounding, they ignored grounding. We'll understand what is grounding. They totally ignored grounding. There was no form of grounding in that because in NLP we don't provide any external source of information. They are weak in understanding a semantic understanding, and they cannot detect the hallucination. So there was a big problem, and RAG has a different kind of expectation. Like RAG has something very different because in NLP we don't provide the external source as one of the information, but in RAG we have a external source. That external source is converted into embedding, and that embedding is stored into vector database. We retrieve the information from that vector database, give that retrieve information to the LLM, and that LLM model creates a very contextual and a fundamental answer for it. So now in the modern RAG system or any of the RAG system, there are few things which should be there, like faithfulness should be there. We'll understand each thing. I'm just giving you the overview. The faithfulness should be there, groundedness should be there, contextual precision and recall, semantic similarity, and LLM based evaluation. Because what RAG is, like fundamentally RAG is in the RAG, the answer should be grounded from the retrieved knowledge from the database. Now you will hear the grounded word everywhere. If you look into any of the vlog, if you Google also about it, you will get to know about grounded. So what is grounded? I'll explain in a very easy way. Now you have an external source, like for example, you have an external document of company policies. So you created an embedding of that company's policy document, small chunks, and that chunking has been created into multi-dimensional vector, which we call it embedding, and you store in a vector database. Now you have created a RAG system out of it. Now you ask the RAG, like, is what will happen to the, or what will be the in-cache value of the left leave, which the leave which you have, yearly leave which has been saved. So in that case, the RAG should, like, you will get the retrieve information from the stored information in the vector database. Now LLM should create the answer just with the information it has retrieved from the vector database. LLM should not use any external knowledge or any of the intelligence, or should not hallucinate in giving the answer. So your final answer, the final response from the RAG system should be very much a subset of your retrieve information from your vector database. In that case, we say that your RAG system is grounded. Means it's grounded. It is not using any external intelligence or adding anything irrelevant to your answer. It is just using the information from the vector database. Now, if the LLM is creating more better answer by adding more relevant information from outside the vector database, then also we don't say it as a grounded system. Grounded RAG pipeline is that pipeline in which the LLM response should be the subset of the vector database retrieved information. This is grounded, and this from there the faithfulness also comes into picture. So that just you would have understood like what was the problem before, what the RAG system demand, and now we'll see that how we can evaluate the RAG system. So we need to understand what is precision matrix, what is recall matrix. There are few matrices, 3-4 matrices. We will understand that matrix, and then we'll see that in the RAG pipeline how we can implement this with the different tools. So RAG evaluation is generally divided into 3 categories. The first is retrieval evaluation, the second is generation evaluation, and the third is system evaluation. So, and that there are 3 phases also in the RAG. The retrieval evaluation means is the relevant information or the relevant documents or chunks are retrieved from the vector database or from the external source. The second is generation evaluation, means is your LLM able to generate the correct response or correct answer. And system evaluation means do your pipeline or the RAG pipeline gives the correct contextual information as an overall. So we have to look into all these 3 parts. So like now in the retrieval evaluation, like retrieving the document chunks from the vector database is not correct. In that case, overall your generation evaluation will be also wrong, because the wrong information fetched from the retrieval category will be passed to the LLM, and then the hallucination will increase and the wrong information or wrong response will be generated from the LLM. So we'll look into each part. So we'll first start with the retrieval evaluation. What are the different metrics in the retrieval evaluation? So now we'll look into 2 very important metrics in the retrieval evaluation. So this is retrieval evaluation, and 2 metrics I have put it together because people get confused between this the definition of these 2 metrics. One is the precision and the second is the recall. So precision is how many retrieved documents are actually relevant. For example, you have asked some query like what is Spark EMR or what is AWS EMR. So you have received some relevant retrieved documents. For example, you have like total number of documents you have received is 10, and the retrieved is 5. Means relevant information in this 10 document is 5. That means your precision will be 5 divided by 10, because 10 is the total number of retrieved document and 5 is the relevant in the 10. So it becomes 0.5. And as per your precision increases, that means your information or your retrieved document has less irrelevant answers. So precision doesn't tell you it doesn't tell you that you have retrieved all the relevant documents. Means your vector database may have 20 total relevant documents, but a high precision means that your retrieved document are actually relevant, but it doesn't mean that all the relevant document inside the vector database has been retrieved. It will be clear like when we'll look into recall. So recall is like how many total relevant documents are retrieved. For example, if for a question query like what is AWS EMR, in your vector database information, total relevant information is 10, but only 2 information has been retrieved. So then the recall at the rate k becomes 2 divided by 10, 0.2, because recall tells you about how many relevant documents with respect to the relevant document actually present is retrieved. This doesn't tell you that in the retrieve chunk how many relevant documents is. So if there is a low precision, if the value of the precision is low, that means your output retrieved data has less of the relevant document. That means you are giving larger prompt into that. Like if you're giving very long and big prompt, then what will happen? The multiple information will be retrieved, but the relevant information will be less. So it also increases your token cost, because if you have a large prompt, obviously your token cost will increase. LLM will get confused because LLM will get all these chunks of data which has less number of relevant data. And if the retrieval is wrong, like we have seen now, if the retrieval is not correct, your LLM gets the wrong input and LLM will hallucinate in that case, and lower answer quality. In recall, as I mentioned, recall look into like how many total number of or what your answer contains, how many part of the total relevant document inside the vector database. So to calculate the recall, you should know that how many relevant information or document are already stored in your vector database. So when your recall is low, that means your answer is not complete. It's an incomplete answer, because your relevant, if you're not getting a full relevant information which is stored in the vector database, that means you are missing out some relevancy, right? Then same thing, business, missing your business rules, or some compliance failure. So recall is very necessary when you are very particular about your vector database information. For example, company policies, or you're working in an insurance domain and your vector database contains all the information related documents, and your recall is low, then that means your RAG system is completely failure for this insurance document. You need to recheck your RAG system in that case. I hope you are able to understand what is precision and recall. So now we'll look into another matrix which is called MRR, mean reciprocal rank. So this is the average of RR. So we'll understand like what's the meaning of it. The meaning is how early your first correct document appear, like how far, like you will get multiple chunks of data. So at what level your correct information is there. So for example, if you are asking the question Spark partitioning guide. Okay, so you're asking some question about the Spark partitioning and you got a chunks. So answer is there in the chunk, but you have to see that at what level it is. It is at the third level, and how many, and the first correct answer is at the third level. So important thing to look into it. For example, you are getting two correct answer, third and fourth, but you have to consider the first answer, the answer which is coming at the first. So third one is the first in this case. So your RR becomes 1 divided by 4, 1 divided by 3, sorry. So it becomes 0.33. Now, for example, in this case, like assume that your third is not the correct, your correct is 2. So that means in that case, your RR becomes 1 divided by 2. Okay. So for multiple queries, you calculate different RR and then create the average of it. So that gives you the MRR. So it is heavily dependent on the rank. So you need to know the rank and then only you can calculate the reciprocal, mean reciprocal rank. This is very useful where chatbot is deployed, where you want more interactive, like in the voice conference you want AI by voice conference, you want company details to be given through voice. In that case also, this is very important. We'll see this. We'll see now that how this MRR is different from the precision and the recall, which we have seen just now. So when we compare MRR with the precision, just this format is not good. Like in this Excel row, I was not able to create the correct format, but I will make you understand. I have added feature here. Then MRR, is it available in the MRR, and is it available in the precision? For example, focus on top K with the ranking, like top level of the information means when your information comes first. So in MRR, first information is the relevant information. If you are getting 4-5 answers, but we'll not consider all the 4-5 answers, we'll consider the answer which is coming at the first. First means at the first time. In the precision, we obviously we take look into the total relevant results. Rank sensitive, yes, MRR is rank sensitive, but precision is partially rank sensitive. I'll tell like as overall, just as for understanding, precision is not rank sensitive, but MRR is totally rank sensitive. Multiple relevant documents, if you're getting multiple relevant documents, MRR, just ignore it because it just look for the first occurrence of the answer. Precision, yes, it counts how many number of relevant documents is received. So MRR is best for question answer search, because in the search engine In the chat bot, you don't want relevant, you want your answer should come first, you want your MRR number should increase. In precision, for the retrieval evaluation, it is mainly based on the, like, if you want to evaluate your retrieval portion, then the precision is the correct. MRR also look into the retrieval evaluation, but the application is more from the searching domain, chatbot, question answer domain. Right. Now we'll see how the MRR, the difference between, or the comparison between MRR and recall. So when we compare MRR and recall, like the feature measures early ranking. Yes, MRR measures early ranking. Recall, it's about the relevance, total number of relevant information. It's not about the ranking. When the measures coverage, MRR doesn't measure the coverage. It only looks for the first occurrence of your answer. Recall, yes, it's measure the coverage, because in recall we look into like how much percentage or how much total number of relevant information present in the vector database has been retrieved. Sensitive to rank, MRR is very sensitive. Recall, no. Focus on MRR in the first hit. Recall is focused when you want to have all the relevant information, like in the insurance domain, in the policy domain, in the factual information. You want all the relevant information to be retrieved. In that case, recall is used. So now we have seen precision, recall, and MRR. There is one more thing called hit case. We'll see it now. Hit rate is very simple. It only checks that your retrieval part, or in the retrieval evaluation, at least you are able to retrieve a single document which is relevant. Okay. So for example, you are getting 10 documents and only 2 are relevant. That then your retrieval rate, hit rate, will become 2 divided by 10. Okay. So it looks into at least one relevant document should exist in your retrieved data. Nothing more, not much detail we need to go into the hit rate. Now we have looked into the retrieval evaluation. Now we'll go into the generation evaluation matrix. So retrieval evaluation was when, depending on the chunks, like when we are retrieving the information from the vector database. So retrieval evaluation focus on the getting chunks, retrieve documents. Generation evaluation focus on the answer you get after LLM, like when you have retrieved the information from your vector database and you give that retrieve information to the LLM model, and then LLM generate the answer. So which kind of answer LLM generates? So there are different matrices to just look into it, how much accurate it is. So the first matrix is faithfulness. Now faithfulness is like, I'll explain first this one. Like if your response is faithful, if every important statement in the answer can be verified from the retrieved document. If your LLM is giving out some information, response or your output, and that output is the subset of your retrieved information from the vector database, that means your system, your RAG, is faithful. If LLM is adding the information or the incorrect information or the correct information also, but that is out of the retrieved information from the vector database, that means your system is not faithful. For example, your retrieve context is like from the chunks you got it, like you've asked the question about the Tesla revenue or something. Then Tesla revenue in 2024 was $96 billion. This you have got from your retrieve information from the vector database. Now LLM is generating the answer. Tesla revenue in 2024 was 150 billion. Now this information, generated information, is not in line with the retrieve context. That means your system is hallucinating. The answer is your system is not faithful. Means your response answer is not faithful to the retrieve context if it is giving a different kind of answer. Now we'll take another example. So I'm asking what are the benefits of EMR serverless. So a retrieve context means from the vector database. Whenever you hear the C retrieve context, that means that information is retrieved from the vector database. When you hear the thing generated answer, that means your answer is the final answer from your RAG system, and final answer is given by the LLM. So retrieve context, the information it is, EMR serverless automatically scales worker based on workload demand. It reduces infrastructure management overhead. Users only pay for resource consumed during job execution. This is the information we got from the retrieve context. Now we'll move into the generated answer from the LLM. It says EMR serverless provides automatic scaling, which is in line with the retrieve context, because in retrieve concept we have automatic scaling. Reduces infrastructure management effort. In retrieve context also it is written, it reduces infrastructure management overhead and uses pay per use pricing. So it's the same as the third line. So that means all the answer from the generated answer is in line with the retrieve context. That means your system is faithful, or this particular, in this particular query your RAG system is performing as a faithful. I hope you understood the meaning of faithful. Faithful is not about the correct or incorrect. It's about your generated answer should be based only on the retrieve context. If your retrieve context is wrong, your generated answer should be also wrong, but the context should be same. The meaning should be same in both the things. The meaning should not be different. So that is all about the faithfulness. So now the another matrix is answer relevancy. So the faithfulness was one thing, one matrix for a rack system. So and in the generation evolution matrix, answer relevancy is another part. Does the answer actually answer the user question? The answer what you have got from the LLM, does it answer your questions? So in faithfulness, it was nothing about correct or incorrect. It was about having same answer in both the system, means retrieval system and in the generation system. But in the answer relevancy, like you've asked some question, is the output of the LLM or output of your rack system answer is answering to your question, then it's answer that's very much relevance. For example, the question is what is vector embedding? The generated answer is vector database are used in AI system. This answer is related to AI and it does not answer the actual question. So the relevancy is pure. Now you understand one more thing. Your answer relevancy will very much depend on your vector database retrieval. So if your retrieval is good, your answer relevancy will increase unless until your system is hallucinating at very high level. Then only your answer relevancy will go down. But in normally, if your system is normal and hallucination is very less, in that case, if your retrieval is of good quality, your answer will be very relevant. It will be the high relevancy. Another matrix is context precision. That means how much of the retrieve context is actually useful. Okay. So now if the retrieval fetches Kubernetes docs, weather report and sports article, then and only Kubernetes docs is useful, that means your system has more noise. So if the context precision is less, then noise will be more. Are you using larger prompt or the higher cost? Obviously, whenever the larger prompts come into the picture, your noise may increase or decrease depending on the context, but the cost will be high because your API call will increase, the token size will increase. Now the another matrix is context recall. Context recall means whether the retrieved context contains all the required information. Like the information is retrieved, that is the correct information, but does it satisfy all your questions, like all the aspects of your questions? For example, the question is explain Kubernetes architecture, and the retrieved information only fetches Kubernetes pod, something about Kubernetes pod, not about the full Kubernetes architecture. That means it misses something. It misses like nodes about the node, about the scheduler, about the control panel. Context recall becomes poor. So if the context recalls become poor, that means more of the relevant information is getting retrieved. Now another matrix is hallucination detection. This is very difficult to detect, and like for some query it will not, there will be no hallucination. For some query there will be hallucination. It's very difficult to manage this. But we'll learn about it. So hallucination occur when your model or when your RAG model creates unsupported facts. For example, retrieved documents contain some information, but your LLM gives more information, irrelevant information. That means your model is hallucinating. Invents number like fake number. It invents, your LLM generates fake references. For example, the context is OpenAI was founded in 2015, but generated from the LLM is like it's 2010. Factually, it's wrong. So the number it generates, the LLM started generating information which is out of the context and which is out of the context from the retrieved information also. that means your system is hallucinating. Okay. So these are the matrices for your modern RAG or the RAG architecture. So we saw till now, we saw like what were the traditional metrics, which is why it was a problematic, why RAGs needs a different kind of metrics. We saw the retrieval evaluation matrix where precision, recall, MRR, and hit rate was there. Now with the generation evaluation matrix, we saw hallucination, we saw faithfulness, we saw other different matrices in the same areas. Now we'll look into how these all fit into the modern RAG architecture. Okay, or when you create a RAG pipeline, how it all fits into it, how you will calculate the number of faith, or how you calculate the faithfulness, which tool will help you to do that. So, or the human can do it, or LLM itself can do it. We'll look into this part. This is going to be very important from now. So now you understood all the base. Now you have got all the base of the matrices, which one to use, which one not to use. Now you see how to use this. One more, one more thing I wanted to discuss, like LLM can also be used as a judge, like faithfulness and all that relevancy. Human can also test that, but it's a very tedious process for the human, and it's also very costly. You have to involve multiple people in for that, just for the testing purpose, evaluation purpose. LLM can be used, like one LLM can use as a, can be as a judge for the other LLM. Like for example, Chat GPT can evaluate another model's answer. So in the prompt, you have to say that evaluate the generated answer using faithfulness, relevancy, correctness, hallucination detection. Give the question, give the context, and check the answer. So this will give you this. If you give this kind of prompt to the LLM, it will do the check. It will evaluate the other model also. But this is fast. Yeah, this process is very fast. But your, like for example, Chat GPT, yeah, GPT-4 is evaluating another model. So your GPT-4 can be also biased. There can be a problem in the GPT-4 itself also. So you cannot rely 100% on an LLM as a judge. But if you don't have too much of time and you want to have a baseline idea, like your RAG pipeline is somehow correct, so in that case you can use LLM as a judge. So now we look into end-to-end RAG evaluation process. So now you have a RAG pipeline. So we have understood all different matrices and where you have to use it. So first of all, you have to build the evaluation data set. Means, means a data set which will check that your RAG system is working properly or not. And in your data set, you should have the original question as a user query. You should have the answer, the ground truth of it, and what are the expected documents you want it to be retrieved. This you should store something, and then that will be used to match the answer. In step 2, you have to evaluate the retrieval layer. Retrieval layer means the document which we get from the vector database. Like you have mentioned, expected documents. That document should be retrieved from this retrieval layer. So here we will test what is the chunking strategy. We'll check the embedding model. We'll test the hybrid search. We'll test the metadata filtering. We'll test the top K retrieval. So here all that precision metrics, your recall metrics, your MRR can be used here. Then you have to set the you have to evaluate the generation layer, in which you have to check about the faithfulness, you have to check about the relevance, you have to check about the completeness and the hallucination rate. For this you can use different tool, which we'll see in the step 4. So step 4 is about performing automated scoring with the help of tools. So tools used are Ragas, DeepEval, TruLens, LangSmith. I'm not going into detail of this tool. If you want me to explain the detail of this tool, how it works, I can come up with a separate video. Otherwise, this will become very big. This video will become very big. The whole purpose was to explain you how the RAG evaluation process can be done. So you can use this tool for the automated scoring. You can have the human validation also, in which what is the failed output, what is the incorrect retrieval. You can look into few answers, few questions. You can check about the hallucination, prompt failure. Then you can put at the end, you can have the production monitoring system, because every time you'll be not looking into all this thing. So you should have the continuous monitoring, which will see the latency, what is the time difference in giving the request and getting the answer, what is the token cost, what is the drift, means answer drift, user feedback, retrieval degradation. You can create a dashboard on this, or you can use the tool and you can create a dashboard on this tool which will give you all this information continuously. So whenever you set the RAG pipeline evaluation, always go into multiple metrics. Uh, one part is always dependent on the other part. So look into multiple metrics, try to calculate multiple metrics, try to create a dashboard or some kind of system which will give you the information regularly, so that you don't have to do it manually. And your vector database refresh is the biggest thing. So by using all this strategy, you will be able to evaluate your RAG. So was the purpose of this video was to give you overall view of how the RAG evaluation process works. This will also help you to clear the RAG interview. So this can add, I'll come up with a separate video for RAG evaluation process particular questions, but this will also help you to join the question with my previous video and give you the overall RAG interview questions. If you want me to explain each tool in detail like Ragas, DeepEval, and if you want me to build a or just show you how we can design a enterprise level RAG pipeline with the evaluation framework and the monitoring framework, please post it in the comment. I will try to bring it in the next video. If you are getting help from my videos, please post your comment, please post your suggestion, your feedback in the comment, and any questions also you can put it in the comment. We'll meet in the next video. Till then, goodbye and happy learning.